8.2 says, how many years will it take for an amount of 75,000 to accrue to 116,253 in an account earning interest of 6.8% per annum compounded quarterly? So here, as I've highlighted, quarterly is a differentiator from our previous question. Now, previous question we were on a reducing balance, and here we are on a increasing balance. So our formula would have a plus I to the power of n like that, because our principal amount, which is 75,000, is increasing to a value of 116,000, and we need to find out how long this would take. So the compounded quarterly now means we are changing the terms of compounding, which means in a year we are compounding 4 times, and we should also divide our interest by 4 such that it applies over an entire year. So with these modifications onto our formula, we can now solve for n, of which is something that I advise you do. Please solve for the variable that needs solving before substituting your values. So here I would like to make n the subject of the formula, and seeing that n is a power or an exponent, it's inevitable that I have to work with logs. So this chapter needs you to have covered logarithms. Then our first step to making n subject to the formula would be to divide by p on both sides. Doing this would have a over p is equal to 1 plus I over 4 to the power of 4n. Then what we'd like to do here is we'd like to make n subject to the formula. The way to do that is to see this as x is equals to base to the power of y. How would you turn this into a logarithm? You would make y the subject of the formula, then you would use this log with the base format and x over there, which is exactly what we're going to do. Our y is 4n, so I'm going to write 4n is equal to log of base. Our base is 1 plus the interest over 4, and then we put the log of x onto it, which is a over p, like that. And we're still not done. We divide both sides by 4, and then that gives us this. Now that we have n as the subject of the formula, we can make our substitutions. So the log of, in the base we have interest, which is 6.8. Remember, you need to divide it by 100, which would give us 0.068 over 4 to the power of there's no power. And then here we put the other value, which is a over p. A is the amount that it grows to, which is 116,253,50, all over 75,000. And then don't forget to divide the entire log by 4. This then gives us a value of 6.4999, which you can then turn into 6.5 years. And that's how you find the amount of time it takes 75,000 to grow to 116,000.